Welcome to the Day 13 warm-up, which is on page 39 in your note packet. This warm-up is intended to help you review the calculator steps. So this warm-up today has to do with vertical motion, which was last night's video. It says an object is propelled straight up from the ground with an initial velocity of 60 feet per second. So first of all, write an equation for the situation. So remember that your equation is going to be h equals negative 16t squared plus v0t plus h of 0. So in this case, I have negative 16t squared plus my initial velocity is 60 feet per second, so that's plus 60t. And then we are told that the object is propelled straight up from the ground, which means that we have an initial height of 0. So you can write plus 0, or you can just leave your answer like this. So part B says, at what time will the object be at a height of 20 feet? So that 20 is what goes in for h. So I have 20 equals negative 16t squared plus 60t. So what you need to do now is you need to subtract that 20 so that I have my equation set equal to 0. So when I do that, I get 0 equals negative 16t squared plus 60t plus 20. Not plus 20, sorry, minus 20. Okay, now we have to go to the calculator. So I need to think, what function am I going to use in the calculator? Well, my equation is set equal to 0. So that means that I need to find my zeros. So right now, get out your calculator, please. Okay, at this point, you should have your calculator out. And here's what we're going to do. We are going to go to y equals and put on our equation, which is negative 16x squared plus 60x minus 20. And you're going to hit zoom 6. Now, I'm looking for my zeros. So we know that this is a parabola that opens down, which means my vertex is somewhere up here. I just can't see it. And I have two zeros, this one and this one. So I need to solve for those. If I hit second calculate, I'm calculating the 0. Okay, now I'm looking for the left bound. So I want to move my cursor over to that 0. So hit right, and you're going to see the cursor. Now, the left bound is when I go left. If I hit left, you notice that the cursor is below the axis. That's my left bound, so I'm going to hit enter. Now my right bound is above the axis then. So I'm going to hit enter, and I'm going to hit enter one more time. So this is my first 0, 0.37. I'm going to do the same thing to find the other 0. So this time I'm going to have to scroll right until my cursor is on this side, which I see it is now. Okay, so my left bound, when I hit left, you notice that the cursor goes up. So that means the left bound is above the axis, and I'm going to hit enter. Then you're going to go down. We notice that the right bound is below the axis, and hit enter one more time. Okay, so now you notice this right here, negative 1e to the negative 11. That's a really small number, negative 1, sorry. Let me find it again. Okay, so that's a really small number. That just means 0. So that's really just 0. And then this is 3.38. So now remember, when you're finding the 0, your cursor one time is going to be above the axis and one time it's going to be below the axis. Okay, so we had two answers. Our first answer was 0.37, 0. And then my second answer was 3.38, 0. So at what time? Well, at the times 0.37 and 3.38 seconds. Now, why do I have two answers? Well, you're throwing an object up. So the object is going to be at 20 feet as it goes up, and then again as it falls back down. Okay, for this next one, what is the maximum height that the object will reach? So my equation is h equals negative 16t squared plus 60t. So I'm looking for the maximum. Now, one thing to be careful of is remember that the equations for B and C are different. This is the equation that we used for C. This is the one, for B. This is the equation that we're using for C. Okay, so by looking for the maximum, I'm just looking for the vertex. So you could do this by hand and do x equals negative b over 2a and substitute back in to find your y. Or you can do this on the calculator. So right now, we're going to find the maximum height on the calculator. Okay, so again, we're going to go to y equals. Now remember to check your equation. I don't need that negative 20. That negative 20 came from the last problem that we did. Now again, go to zoom 6 so that our window is fixed. And we're looking for the maximum height. Now this is a parabola that's opening down, so the maximum is somewhere up here. So I'm going to go to second, calculate, and I'm calculating the maximum. The left bound just means that I'm to the left of the maximum. Well, if my maximum's up here, then I'm to the left of it. That's okay, so I'm going to hit enter. Right bound means to the right of the maximum. If my maximum's up here, my right bound is somewhere over here. So I'm going to hit right until that cursor comes all the way back over to the right side, which I see that it does now. So I'm going to hit enter. Do I want the calculator to guess? Yes, I do. So I hit enter one more time. So my maximum occurs at 1.875, comma, 56.25. Okay, so again, our maximum happened at 1.875, comma, 56.25. Now, remember that your x is time and that your y is height. So we would say that our maximum height is 56.25 feet after 1.875 seconds. So that would be for part C. Now for part D, when will the object hit the ground? So hit the ground means that my height equals 0. So I'm going to take my equation, my negative 16t squared plus 60t, and I'm going to set it equal to 0. Now, on the calculator, because my equation is set equal to 0, I'm solving for the zeros. I'm going to use the 0 function. So let's look at how to do that on the calculator. Okay, so first thing that you want to do is hit y equals and make sure that your equation is in correctly. Anytime that you do a problem like this, you always want to start by making sure you have the correct equation. I'm going to hit zoom 6. Okay, so I'm solving for my zeros. So I'm going to notice I have 1 0 here at the origin, and then this is the 0 that I'm really interested in, because remember my object's going to go up and it's going to come back down. So I'm interested in when it comes back down. If I go to second calculate, I'm calculating my 0. The cursor's at this 0 and I want it at this one. So I'm going to hit right until the cursor makes its way over there. You might have to go slow so that you make sure you see it. Okay, now left bound. I'm going to notice when I hit left, my y is getting bigger. So that means the left bound is up here. So I'm going to hit enter. Now when I hit right, my cursor is going lower. So my right bound is below the axis. Do I want the calculator to guess? Yes, I do, so I hit enter one more time. So my 0 occurs at 3.75. Okay, so answering the question, when will the object hit the ground? Well, the object will hit the ground after 3.75 seconds.